Hello, my dear students. Welcome to our lesson for today.
Today, we are going to discuss polynomials. We are going to discuss basic concepts about polynomials. We need to review our knowledge about polynomials so that we will understand our next lesson, which is about rational algebraic expressions. Are you ready? Let us first have an activity. In this activity, we are going to identify the differences between polynomials and not polynomials. I will be showing you expressions which are polynomials and which are not polynomials. And please kindly take note their differences. Let's start. This one is polynomial. This one is not polynomial. Can you see a difference between the two? Next, another polynomial. And this is not a polynomial. Third, a polynomial. This one is not a polynomial. Another example of a polynomial. This one is not a polynomial. Another example of a polynomial. And this expression is not polynomial. Now, you can pause this video so that you can easily identify the differences between the two. So, let us answer the question, what is or are the differences between algebraic expressions and polynomials? Let's see if we have the same observation. Expressions with negative exponents are not polynomials, meaning to say polynomials have positive exponents only. Another observation, expressions with a fraction exponents are not polynomials, meaning to say polynomials should have a whole number exponents. Another observation, expressions which are the variables found in the denominators are not polynomials. Why? Because the expression indicates division. Hence, it is not considered as polynomials. So if the expression is not considered as polynomial, it is called algebraic expression. Algebraic expression is a constant, a variable, or a combination of constants and variables connected by fundamental operations, addition, subtraction, multiplication, and division, including raising to a power and extractions of our roots, or square roots, uh, cube roots, and so on. So that is called algebraic expression. So what is a polynomial? A polynomial is an algebraic expression of one or more terms each of which is a product of constants and variables, where each variable is raised to a positive integral exponent, including 0. The operations involved are addition, subtraction, multiplication, but not division. In other words, polynomial is a special type of algebraic expression. Pero its exponent are positive, which is not negative, and an integer, which is not a fraction exponent. But it could have an exponent of 0. Also, the operation between polynomial are the fundamental operations except division. So what are the basic parts of polynomials? First, constant. It is the numerical value in the expression, meaning to say, ang number in the expression. Okay? So here are the examples of constants. Okay, next, we also need to know what is a variable. A variable is represented by a letter in the alphabet. Okay, you can use any letter in the alphabet, but these are the known variables. A, B, C, D, X, Y, Z. Okay, now a variable is just like a container, and it has its own value. Okay, it represents a value. So that is a variable. Next is a term. How do we identify a term? A term can be a number or a variable or a product of a number and a variable. Remember that a term is separated by a plus or a minus sign only. Okay? Examples. Number 1. How many terms do we have? 1, 2, and 3. There are 3 terms. In second example, how many terms do we have? 1, 2, 3, 4, and 5. Meaning to say, we have 5 terms. As you can see, a term can be a number only, can be a variable only, or a combination of the two, as long as they are separated by a plus or minus sign. Okay? Another example. 1, 2, 3, 4, 5, 6. That's right. We need to include this one. So we have 7 terms. In the fourth example, 1, 2, and 3. Why is it that this expression is considered as one term? Because the operation between the two is multiplication. We can multiply 12 and 3, and then x and y, right? So this is considered as one term, another term, and another term. So all in all, we have 3 terms. In the last example, how many terms do we have? That's right. We have 2 terms, which are 1 and 2. So we have 2 terms. How do we identify like terms? These are terms that have the same variables raised to the same exponents. Example, 3x squared is the same term as 5x squared. It's just the same as we say 3 apples and 5 apples. Okay? So they are the same. Another example, 13ab cubed and negative 6ab cubed. As you can see, they have the same variables, which are a and b, and they have the same exponents. Say a, the exponent is 1, say b, the exponent is 3. So they are the same, or like terms. Another example, 23x cubed y squared and 4x cubed y squared. They are the same terms. But what if in the 4x cubed y squared, we are going to interchange the exponent? This one will become 2 and this one will become 3. Are they the same terms? That's right. No, they are not the same terms. Yes, they have the same variable, but the exponent is different. So that's how you identify like terms. Now, there are different types of polynomials. One is monomial. It is consists of only one term. Binomial, which is consists of two terms from the term bi. So there are two. And trinomial if it is consist of three terms. And it is called a multinomial if it is consists of two or more terms. Let's have a drill. I want you to answer on your own and check if you got the correct answer. Identify if the following is a polynomial or not. Okay, let's start. Number 1. Is this a polynomial or not a polynomial? Observe their exponents and their operations. This is a polynomial. Good job. How about the next example? Again, let us check their exponents. That's right. This is not a polynomial because it has a fraction and a negative exponent. This is just an algebraic expression, correct? Number 3, observe that this variable is in the denominator of a fraction, meaning to say the operation between the two is division. And on the right side, the exponent is a fraction. Therefore, this is not a polynomial. Number 3 example. Observe. Yes, we have a fraction here and another fraction here. But let me ask you, is the variable in the denominator of the fraction? Hindi. Very good. And their exponents are positive, integral. Therefore, this is a polynomial. Okay? So remember, It's okay that the constant are fractions, as long as variables are not found in the denominator. So this is a polynomial. Good job!
Thank you for watching. See you again in our next lesson.